Okay, welcome to our first flipped lesson. As you can see, we're going to be dealing with section 7.5, which is on rational numbers as exponents. Remember, rational means fraction. Exponents that are fractions. So we've got a little history on this. Let's go ahead and take it to the next level. Relationships that we're going to need to know in order to be successful in this unit is to remember that for positive numbers and zero, basically not negative numbers, if you take a power and then a root, it's the same as taking a root and then a power. So we could take the mth root of a to the k, or we can take the k, put it on the outside, and do the mth root of a first. Whichever way we want to do it is up to us, and we'll practice a few problems in just a moment. Also want to remember that radicals can be expressed as powers that are rational numbers. So fractions, so maybe we have it as a to the m over k, and that's the same thing as the mth root of a to the k. And lastly, how do I get rid of this? And lastly, we are going to talk about negative exponents. So if I have a to the negative m over k, that's going to equal 1 over a to the positive m over k. So no different, just the fact that they're fractions doesn't change the fact that if you have a negative exponent, you flip it on the other side of the fraction bar and make the exponent positive. Alright. Make sure you get those written down, and we're going to move on to the next page. What is going on with that? I don't want that there. Pause. Alright, so let's practice a little bit, see which technique or which rule or formula or process we want to follow. So you can see we have examples in practice. We're going to try and simplify. Sometimes by simplify it means to rewrite just with a fractional exponent, or to rewrite in the radical. So going back and forth between the two forms is sometimes a form of simplifying as well. As we can see with problem number 1, we're trying to simplify the cubed root of 8 squared. We have two approaches we can take on this. We can find the cubed root of 8 squared, which is the cubed root of 64, and then maybe you know 64 is a perfect cube, maybe you don't. 8 times 8, 4 times 2, 4 times 2, 2, 2, 2, 2. It's cubed root, so we're looking for 3 of a kind, and we have 2 3 of a kinds here, so we end up with 2 times 2, which is 4. So final answer is 4. That's one approach. The other approach we could take is to use one of the things we wrote down on the front side, or on the top above, on your worksheet, and we can do the cubed root, oh that's not what I wanted, we can do the cubed root of, first erase that, boom, cubed root of 8 squared. And I think we all know by now the cubed root of 8 is 2, so I end up with 2 squared, which then gives me my final answer of 4. I kind of like that approach a little bit better. It shows some understanding of not only the rule we were talking about, but because we know the cube root of 8 is 2. Alright, moving forward, problem number 2, we have the square root of 5x quantity cubed. Okay, so there's a couple different ways we can approach this. I like to write this as the square root of the quantity 5x cubed, which is the square root of 125x cubed, which if we break down 125 and we break down x cubed, we end up with a 5x on the outside and the square root of 5x on the inside. The only thing we need to keep in mind is that we have a square root, so an even index, so we want to have absolute value brackets. And so there's how we would simplify the square root of 5x quantity cubed. So first look at it like that. Alright, very good. I hope this is going well for you so far. And we're going to continue on looking at problem number 3. So problem number 3, go ahead and create some space for it. We have the cubed root of 9x squared y, the whole thing squared. So what I'm going to do, because I know the cubed root of 9 is not a whole number, we can't take the cubed root of 9, I'm going to go ahead and take this 2 and distribute it in. So I get the cubed root of 9 squared, x squared squared, we multiply the exponents there, and then y squared. Alright, so there's the beginning. Now what I'm going to try and do is I'm going to try and break this down. Why don't you take a few minutes, try and break this down, and check back with me in about when you're finished. Okay? Good luck. Go ahead and press pause on this. Take some time to do this problem, and then press play when you're done and see how I did compared to you. Thank you very much. Give it a try. Alright, so let's see, I'm going to go ahead and set this equal to the cubed root of 9 squared, that's 81, and then x to the 4th, I'm going to write as x cubed times x just to show you why I'm pulling out an x, and then y squared is going to be stuck in there. Now 81 does break down. I'll show my work over here and I'll have to erase it. 81 is 27 times 3, or 9 times 9, it doesn't matter which approach you take. 9 times 3, and then 3 times 3. It is a cube root problem, so 3 of a kind. So I'm going to pull a 3 to the outside. I'm going to pull this x to the outside, and then that's all I can pull out, and then I have times the cubed root. I still have this 3 left in. I still have this x left in, and I still have y squared left in. So here's my final simplified form, quote-unquote simplified form, of problem number 3. Alright, let's see if you can simplify problem number 4 on your own. Now, I hope you put me on pause, because here's the answer. Boom, 27. Hopefully you got it. If not, you can see my work. I chose the method of taking the square root of 9 first, and then cubing it. It's a lot easier to do that than to do 9 cubed and then break that down. So I chose square root of 9, cubed it. Square root of 9 is 3, 3 cubed is 27. Alright, good job. Keep working along. If you ever get stuck or don't know what's going on, feel free to put it on pause and try again. Alright, thank you very much. Oh, time out. I just realized I never had my my microphone plugged in, so hopefully this will take care of the annoying poking. Alright, so let's see, we have the 7 to the 1/2 power. Let me change my view so I get a little bit larger here, and scroll down. Hopefully my viewing window is still working. Okay, we have 7 to the 1/2 power. There's not really much we can do here other than rewrite it as a radical, and so we'll write it as the square root of 7 and be done with it. Alright, and lastly, we have the 4th root of 25 squared. A couple different ways we can approach this. Completely up to you. Unfortunately, the 4th root of 25 doesn't simplify, so if I try to do the 4th root of 25 squared, I'm going to run into a problem. It doesn't really work out very well. But what I can do is I can do the 4th root of 25 squared, which 25 squared is 25 times 25. See if maybe this can help you get to a solution or a simplification. Put me on pause, try and break it down, see how you get your answer, and then when you come back to me, you'll see how I approached it. Alright, good luck. Okay, so 4th root of 25 times 25, I rewrote 25 as 5 squared twice. 5 squared times 5 squared is 5 to the 4th. The 4th root of 5 to the 4th is simply 5. Alright, so that would be something that hopefully we could do without a calculator just by working through the mathematics of it. Alright, let's move on to the next. Here we have, continuing along with rational numbers as exponents. Can we simplify the 6th root of 2 to the 12th, a to the 6th? please notice that we have an even index and we have a variable, so there's a good chance I'm going to need absolute value brackets here. Simplify this, see how it goes, check back with me in a few minutes. Put me on pause now. I think the best approach on this problem is to rewrite it as rational exponents. 12 over 6, 6 over 6, so I end up with 2 squared times a. 2 squared is obviously 4, and then we have the a, and again I remembered to put the absolute value brackets. Alright, so now we move on to a negative exponent. Anytime you see the negative exponent, remember, this is the rule of exponents. Whoa, what happened? Equals 1 over a to the m. If I had the negative in the bottom, then I would, then I would bring it to the top, a to the m. So this is like a little thought bubble for us anytime we have negative exponents. Here I have a negative exponent, so the first thing I'm going to do is write this as 1 over 8 to the positive 1/3. Then I'm going to rewrite it as a radical, 1 over the cubed root of 8. Hey, the cubed root of 8 showed up again. I know what that is. 1 over 2. Boom, there's my final simplified form of 8 to the negative 1/3. And then, oh, here we go. We got a negative exponent. Let's bring it to the other side of the fraction bar and make it positive. 16 to the positive 3/4. And then what are we going to do with that? Ooh, I have an idea. Let's put it into radical form and see if it can be simplified. Put me on pause, try it out, come back and see how I do it. See you in a few minutes. Okay, so did you get 8? Hopefully. And your approach may have been different than mine, or may have been the same. I like to think I used the most efficient approach, but maybe not. So once I added a 16 to the 3/4, I then wrote it as the 4th root of 16 cubed. And I don't like to do 16 cubed if I don't have to. So I then rewrote it as the 4th root of 16 quantity cubed, because I know the 4th root of 16, and if you don't yet, you should start to figure it out. 16 does break into 4 times 4, which is 2 times 2 times 2 times 2, so 16 is really 2 to the 4th power. The 4th root of 2 to the 4th is 2, and then I have that cubed. 2 cubed is 8, and that is how I got 8. Alright, hope you guys are having fun, enjoying this little video. You know, it's a new experience for us all. This was supposed Okay, so you can see here, this is a worksheet that says in-class group practice. We'll work on this in class tomorrow. So what you're going to have to show me for homework are these notes. So come in, show me these notes. After you show me these notes, well, while you're showing me these notes, I'll have you guys working in groups on this practice to see if you have an idea of what we're doing. But as you can see, these problems have a higher level of difficulty than the ones we went through in the notes. So it will be nice to have the support of your friends around to kind of see how we do these types of problems. Okay, I hope this was helpful, beneficial. I'll be looking for some feedback from you guys. Let me know if you like it or dislike it. Otherwise, I'll see you in class tomorrow.